Hello, in this video I'll be talking through another kinematics question. So we've got a particle P moving along a straight line, so one-dimensional kinematics, such that at time t, positive t, we've got the velocity modelled by this function here. So I'll write that out a bit larger just in case it isn't coming out. Velocity is 12 plus 4t minus t squared. So that's not a constant acceleration, because for constant acceleration, if you remember, we get a linear function of v. So this is variable acceleration. So we're going to be using the language of calculus, talking of rates of change and accumulation of quantities, rather than just changes and averages. Even though they're really the same thing, we just need to be a bit more specific when we're dealing with variable acceleration. So we need to find in part A the magnitude of the acceleration of P when P is at instantaneous rest. So instantaneous rest means that V is equal to 0. So we need to solve this quadratic for V is equal to 0. I'm going to flip the sign on everything because I find it a lot easier to spot if something factorizes if the coefficient of t squared is positive. So change the sign of everything and put v equal to 0. And then, yes, that is going to factorize into t minus 6 and t plus 2 is equal to 0. And we know that t is positive, so we need that t is equal to 6 seconds. And we need to find the magnitude of the acceleration when it's when it's time t 6 seconds. So the acceleration is the rate of change of the velocity, which is going to be differentiating, and we need to differentiate the original function, not this quadratic here, because also I've multiplied everything by -1 there. I've done a transformation on that function. So we have to go back to the original function and say that we've got 4 minus 2t. So at t equals 6, a equals 4 minus 12 minus 8 meters per second squared, and we want the magnitude of that acceleration. So the magnitude of the acceleration is 8 meters per second squared. So that's all ticking along fine. And then we need to find the distance traveled by P in the interval 0 to 3 seconds. So for part B, remember that distance traveled is the accumulation, or at least the displacement is the accumulation of the velocity. So we need to make sure, if we're looking at distance traveled, that we don't have a change in sign of the velocity. And are we going to have a change of sign in the velocity between 0 and 3 seconds? Well, we can come and look at our velocity function, which is this. So let's check. So this is what our v is minus t minus 6. I'm just putting that minus back in again to get the original velocity function. So we know that this is a negative quadratic, if I was going to do a mini sketch, with roots at -2 and 6. So it's going to look something like that. That's at -2 seconds, that's at 6 seconds. So from 0 to 3 seconds, we're wanting to get this area here. That's the accumulation of our velocity, and there's no change in sign. So we can just do a straight integral of this, and that will give us the distance as well as the displacement. So the velocity function hasn't crossed the x-axis. So that's fine. So we can say that our distance is the accumulation, the integral of the velocity going from 0 to 3 seconds. So we need to integrate our velocity function of 12 plus 4t minus t squared with respect to t, which is 12t plus 2t squared minus t cubed over 3. And we need to calculate all of that between those times, 3 and 0. So the zeros will all be zeros because everything's got a t in it. So all we have to do is put the 3's in, and that will be enough. So we've got 36 for the first one, 2 times 9 for the second one, and then we've got 27 over 3 to take off at the end, which is going to give us 45 meters. Whether they'd be that bothered about this checking, I mean, they're only allowing 3 marks for it here in a question, so sometimes they don't put these things on the mark schemes that you need to check that the distance and the displacement would be the same. You know, this idea that the velocity hasn't changed sign, but it's something that you want to do, regardless of whether it's on a mark scheme or not. You need to make sure that you are actually calculating the right thing, and if you've got a change in the sign of the velocity, then you need to break up your integral into separate steps if you want to get what the distance travelled is going to be. So yeah, a nice question again.